Hello guys, welcome to our lecture on human impacts to the hydrosphere. Sorry, that's our unit. Our lecture today is all about microplastics and plastics in the water. Here's your vocab. Pause the video, take these vocab words, and we'll get started. So if you are tuning in with us electronically, it's really hard to do a think, pair, share, but this is something that you can at least do the think and pair. You can share with your parents or whoever's around you, brothers or sisters. So here's how you do it. So you think first about the question to yourself. Then after you've thought about it yourself and come up with your own answer, you're going to pair up with your neighbor and discuss what both of you thought about. Afterwards, you're going to share with the class what you thought, or maybe just share with a parent. This is your bell ringer. So in what ways do humans use water? List them below. Do you think humans can influence the water cycle and how much water is available? Yes or no, and why do you think that? So these are your think, pair, share questions. Go ahead and try it. Talk it over with someone in your household. And then here we go. We're getting started with the notes already. So, okay. Terms before we begin. So we've defined these already in a previous lecture, but a non-point source pollution is a pollution that results from many different sources, usually carried by rain runoff. You can't really detect where exactly the pollutant is coming from. A point source is different because you can actually trace that pollutant all the way back to its source. So you can point to who is polluting the water. You can't do that with a non-point. It's just coming from all over, and it's often a result of runoff. Now, here's some examples of how we pollute the water, how we use the water. So we use water for irrigation, you know that. We use water for things like recreational uses, like fishing, or even fishing as far as like food and an economic benefit. We use water for electricity in the case like right here with our hydroelectric dam. And then we use water for transport too. We talked about that when we were discussing the Mississippi River. So our hydrosphere is very, very, very important to us. But here's the problem. We're impacting the hydrosphere quite a bit. That's what this whole unit is about. That's what we're talking about. And honestly, our effects of it on it are pretty negative. So here's one of the things that we're having troubles with. So we are overusing water. We talked about this in a previous lecture, but we're going to go over it again because it's something that I think everybody needs to understand. So because our global population is increasing, the amount of water needed to sustain everybody is also increasing. You've seen this graph before, but in 2007 there were 6.6 billion people, and we had approximately 200,000 kilometers squared amount of water, potable water, water that we're able to use to drink and to create food. But in 2050, we're projected to reach a world population of 9.3 billion, and the problem is that in 2050, our usable water is the same. So that means that the amount of water per person as the population grows is going to be less as the population grows. So maybe to put it in terms that you might understand that these are not to scale or specific, but say today I have like a whole Olympic swimming pool amount of water per me. If I were to divide it evenly amongst the world, that's what I would have. But as the population grows, that swimming pool is going to shrink to maybe not an Olympic size, but like just a regular backyard swimming pool. And then maybe it's going to shrink even more to just like a bathtub full of water. And we're going to get to big problems when the amount available per person is something like a gallon of water per person, because that's not sustainable. We need more water than that. So as our population grows, we're not only wondering how are we going to feed the growing population, but how are we going to provide enough clean and sanitary water per person. Now, we did discuss this before, but what happens when the water isn't evenly distributed? So in theory, we should have the same amount for each person, but we know that's not true because even today people don't have available fresh and clean and sanitary water. Things to think about. So the other thing with the overuse is our groundwater. So we're taking water out of our aquifers, our underground water storages, at a rate that is faster than it can be recharged. You can see that on this graph right here of California. So dark red is bad. That's equivalent water height, so what it was to what it is now. You can see that 0 is right there, but we're going deeper and deeper and deeper. Our water height is shrinking smaller and smaller and smaller in these underground aquifers right here. We talked about it, wells and aquifers can actually dry up, and then one of the issues, not only do you not have water, but subsidence can happen where it's the shrinking of the land. You'll start getting like sinkholes and stuff. It's not good. And this is just the change in 2011 versus 2012 versus 2013. So you can see that California was really, really pulling on that underground aquifer and taking the water out of it. Now, this is subsidence in San Joaquin Valley, California. So from 1925 to 1977, the land elevation fell almost 9 meters. So you can see there was the ground in 1925, 1955 to 1977. So it was actually shrinking. Funny. So in this case, it wasn't a whole sinkhole. It was just the ground was going down, down, down. This is a video that we're going to watch in class. I will link this to you. You're going to answer the questions on your note sheet about it, but it is all about the hard word to pronounce, Olagala Aquifer. Very interesting, and how the industrial farming is actually making it worse. But I will link that to this so you can watch that, because that's part of your notes you need to fill out as well. But we're going to keep going. So again, the problem with overuse is we're not only just drying up our wells, we're actually contaminating our wells around the coastal areas with salt water. We call that saltwater intrusion, and we've talked about this before. So once salt water intrudes onto your fresh water, it makes your well useless. So here we've got a little house or something right near the sea level, and normally that blue speckly line is right here straight. But because they have this well right here, it's actually causing there's a pressure system created from the well because it's sucking up the water, but it's not just sucking up the water from like this direction, it sucks it from straight down like you would normally suspect, but unfortunately it's causing the salt water to go in towards the well as well. And so in coastal areas where cities are growing like Wilmington, we're having more and more of this saltwater intrusion into our well water, which is not good. It's contaminating the drinking water, and then once it's done, you can't do anything about it. Here is another video that we're going to watch on saltwater intrusion. I'll link that as well. That explains it a little bit better. Human impact. So not only do we kind of pollute our water, not only do we pollute our water supply, we also alter it for our own human benefit. So in this case, we built a dam and an irrigation canal, and you can see how from 1970 to 1999 to 2014, they basically caused the dry up of this sea, the Aral Sea. So building dams and diverting water for irrigation can decrease the amount of fresh water available for people who live downstream. So you're getting lots of water, that's great, but downstream, are they? So this happened because they were pulling water out. I think I have another picture of it. Yeah, so that was then. This is more recent picture. So somewhere downstream that was feeding into this lake, they have decided to create a dam and use it for irrigation, and it actually caused the dry up of this lake. It's almost not even there anymore. It wasn't a lake. It was a whole sea. Now it is a little lake. We can also overuse surface water. So overuse of reservoirs can deplete the amount of surface water available. Example, Lake Mead right here. You can see where the water level was to where it is now. So somewhere, some way, somebody is taking that surface water and using it somewhere else, decreasing the availability of that fresh water because the water's going in. If they're using it for irrigation, the water's going into plants. Another big impact that we have on our hydrosphere is the urbanization, which means the building of cities. So urbanization increases the amount of paved surfaces in an area and decreases the amount of soil in the area. Now that doesn't sound like a bad thing, but it actually is, because our paved surfaces are what we called impermeable, if you remember, and that means that when the rain falls on a parking lot, the rain, as you've seen, is going to puddle down and go into drain wells. It's not going to be able to sink and go into the ground, the soil, like it should have. So And it also causes, not only is it not going into the soil, recharging our aquifers like we need, it is also picking up whatever was on the parking lot and pulling it down into the water supply too. So if it was dirt, it's there. If it was cigarette butts, now it's in the water supply. So all that trash and all whatever it is, even if it's just chemical stuff or like salt from maybe when they salted the roads for ice, now that's going into this the drainage things wherever they go, into the sewer or into a river, and polluting that as well. So when there's rain, all the water runs off instead of infiltrating into the ground. 1 inch of rain on an acre of woods produces no runoff. 1 inch of rain on 1 acre of asphalt produces about 26,000 gallons of runoff. Now, runoff is bad, we said, because it takes with it pollutants. So that's not good. Human impacts urbanization again. So runoff from paved surfaces carries dissolved pesticides, herbicides, oils, and other pollutants from homes and businesses. This, you can see the oil right here, the shiny part of the water. We talked about that. Not good. Runoff will enter the surface water sources, such as like rivers or lakes or even the storm drain, contaminating the water source altogether. Not good. That's why you should wash your car on grass instead of in the on the parking lot or on your driveway. Another problem with urbanization that we talked about is thermal pollution. Now, we talked about how thermal pollution can come from like power plants and stuff, but asphalt is hot, especially down here. If you think of like the hot beach or even just like the hot parking lot, it absorbs more heat than soil or vegetation, so the runoff from the pavement is warmer, and this increase in temperature can be harmful to aquatic ecosystems that the runoff flows into. We talked about that. A lot of the aquatic ecosystems are very, very finicky. They're very specific to their needs and like their pH level and their temperature. So even just a little variation caused by warming up the water on the pavement is a big deal and can cause ecosystem chaos. Agriculture is a big thing. We talked about this, and we'll talk about it some more. Agriculture runoff is one of the main pollutants that we have in our hydrosphere. So the high level of fertilizers is mainly one of the issues. It causes eutrophication, which we're going to do notes on Wednesday, I believe. But this eutrophication causes mass algae blooms. When the algae dies off, the bacteria that decomposes it uses all the oxygen in the water. And so because we have the algae blooms, and then the algae dies, and then the bacteria comes in to do what it does and decomposes stuff, but it's using all the oxygen. And because there's no oxygen in the water, all the fish die and all the other plants die, and then the water becomes a dead zone, which is not good. Here is just it in 6 little itty bitty steps, but like I said, we're going to take a whole day to talk about this. So the nitrogen and phosphorus of the fertilizers spread on the fields to help the crops grow. We talked about how nitrogen and phosphorus are limiting factors for plants. That's why we put it on our fields, so that we get bigger crop yields. When the rain comes, it causes the runoff to go into streams and rivers and lakes. The runoff increases nitrogen levels and phosphate levels, and I talked about it. It's a limiting resource for many plants. So the plants cause the nitrogen and phosphorus, because that was a limiting resource, causes a huge growth in the algae bloom, or algae, any photosynthetic thing. So even here our seaweed grew, which was good, but also the algae grew as well. Now large amounts of algae die and because of competition, and are decomposed by bacteria, and that uses up much of the oxygen in the process. Because there's no oxygen, the fish and the plants die, and the ecosystem is destroyed. So this is a really big deal, and it's actually really, really bad. So you can see algae comes in all kinds of beautiful, deadly, beautiful but deadly. Algae comes in all kinds of different colors and different shapes and sizes, but if you see an ecosystem that looks, or a waterway that looks like this, it is not good at all. So what can we do? One of the biggest things is drip irrigation. So drip irrigation is actually like putting the water exactly where it needs to be. You're not, the big things that you see that are spraying water all over, they're huge, they look like this. Those are they're not bad because they water the plants, but they cause a lot of runoff, so they are bad. Drip irrigation goes right along here. It's much lower to the ground. It's much more expensive because you can't move it like the other one, but it will target the plants exactly. See? Compared to this has a lot of runoff right here. Drip irrigation extends watering times for plants and prevents soil erosion and nutrient